Hey guys, Mr. Bowen here. Today we are going to talk about elements and compounds, and I hope that by the end of this lesson you'll feel comfortable and confident in being able to differentiate between an element and a compound by defining and giving examples of each. Also, you'll know if you've succeeded by correctly identifying substances as elements or compounds by the end of this lesson. So let's quickly review what we've done so far in this unit. We've learned that matter is anything that has mass and takes up space. We've also learned what is not matter, that energy, such as light and sound, those are not matter. We learned about elements, and we learned that an element is a type of pure substance that is made up of only one type of atom, which gives it unique properties. If you see the visual to the right here, copper is an element made of copper atoms only. Carbon's always made of carbon atoms. Helium is only made of helium atoms, and each of those atoms look a little bit different than the other elements. So we've also learned that substances have different properties because their atoms are different. In order to understand the difference between an element and a compound, there are two things you're going to have to be able to use and read to successfully do this. They are chemical formulas and models. We're going to go over both of those and then introduce what is a compound and how is it different from an element. This is an example of a chemical formula. It tells you which elements are present in the substance, and they use element symbols from the periodic table. You may know from prior grades or have noticed that each element symbol has one capital letter. Some element symbols have two letters, but the first letter of the symbol will always be capital. So H for hydrogen and O for oxygen are used in this example. You'll see that the capital letter H means hydrogen, and the little 2 here, which is called a subscript, tells you that there are 2 atoms of the element hydrogen in this formula. O shows you that oxygen is present in this substance, and there's no subscript, there's no number there, so that means there's only one atom in the formula to make water. So every water molecule, which is the small particle of water, each water molecule has 2 atoms of hydrogen and 1 atom of oxygen. A model of H2O, or water, is going to be an image that shows you what the particles look like. They're often used with different colors. So you might see 2 different colors to represent the 2 different types of atoms, or the 2 different elements that it takes to make water. So on the left here, you see the chemical formula, H2O. On the right, we have several different water particles called molecules. Notice that each particle has 1 red and 2 gray atoms. The red is oxygen because there is only 1 atom in the formula, and the 2 have to be hydrogen because there's a 2 next to it. So hopefully by the end of this lesson, you'll be able to look at both the chemical formula and the model and be able to identify, is this an element or a compound? We can see here by the model, there are 3 different atoms made from 2 different elements in a water molecule. Both show you that water is made of 2 different elements. So looking at more chemical formula examples, you'll see that some element symbols have 2 letters, such as copper. Copper has a capital C and a lowercase u as its symbol. Sodium has Na. Notice that the N is capital. And chlorine, which is Cl with a capital C. Anytime you need to know how many elements are in a formula, you just have to count how many capital letters are present. So take a minute and pause this video, if you'd like, and try to come up with how many elements are in each substance. So count the capital letters. You may pause now. As we reveal the answers, I've highlighted the different elements. So number one, H2O, has two elements, capital H for hydrogen, capital O for oxygen. Number two has two elements, capital N with a lowercase a, and A is sodium, and there's a capital C next to the Cl for chlorine. Number three, Au is gold, that's just one element. Number two, Fe is one element, that's iron, and O for oxygen, so that makes two elements in this formula. Number five is a little bit tricky. There are two capital O's in there. So there are, how many different capital letters are there? There's 1, 2, 3, 4 different elements in this formula. So there's capital N for Na, a capital C for carbon, two capital O's and a capital H, sodium, carbon, oxygen, and hydrogen combined to make this. That's actually the formula for baking soda. So there are four different capital letters, therefore four different elements in that formula. Let's take a look at some models now. How many different types of atoms are in each of the following? So take a look at these four examples. This one, this one, this one, and this one. And these four examples, these are models, how many different types of atoms are there? So how many different color atoms do you see? You may pause this video and think about it for a minute if you need to, and then resume for the answer. Okay. So in this substance, there's one type of atom. They're all the same. That means that this is likely one element. Many atoms of the same element. Below it, we have two different colored particles. There are two types of atoms. Therefore, this substance is made of two different elements. This example shows that there are two types of atoms in the top right. They're the red and the gray. This is our water example from earlier. So if there are two types of atoms, that means this substance is made from two different elements. The lower right, let's count them. We have a gray atom, a black atom, a red atom, and a blue atom. So that's four different types of atoms. Therefore, this substance must have four different elements in it. So the number of types of atoms is the same as how many elements are in each substance. Going back to the chemical formula, we would just count the capital letters. But looking at a model, you're going to look at how many different looking particles there are. So now let's talk about what is an element and what is a compound. We know from before that an element is a pure substance made up of one type of atom. We can see what a model might look like, where these are all the same color and same size atom. This might be an example for iron, like this frying pan or cooking pan. For the compound is a substance made of two or more different elements that are chemically bonded. They must be chemically bonded to form a new substance. So we have H2O for water. Now when you look at water, you can't tell without seeing its atoms that it's made of two different substances. That's because hydrogen and oxygen actually bond and form a substance with new properties. We talked in class about how hydrogen by itself is a gas, oxygen by itself is a different gas. At room temperature, their natural state is a gas. When they bond to make water, now all of a sudden water has new properties. It's a clear liquid. That's because water is a completely different substance from hydrogen or oxygen. All of our matter can be categorized as either an element made of one type of atom, a compound made of two or more different types of elements, or a mixture, which we'll get into later in this unit. For the rest of this lesson, I want you to stay focused on what makes something an element and what makes something a compound, and how are they different. Let's go through some basic examples of elements. If you remember from our objective, to demonstrate your understanding, you should be able to identify examples of both elements and compounds. Anything on the periodic table is considered an element. And the four most common elements in the universe are hydrogen, oxygen, nitrogen, and carbon. Let's go over some other common elements. We have neon. Neon is a gas. It's found in lights such as this one in the picture, like the open sign. Bright lights, often made of neon. We have gold, solid object, worth money. Lithium. Lithium is often found in batteries, your cell phone batteries or watch batteries. Helium is a gas. When you blow up balloons with helium, it'll make them rise, or it'll make your voice sound funny if you consume it out of a balloon. So now that we've gone over some basic examples of elements, let's look at some examples of compounds. Again, a compound is when two or more different elements are chemically bonded. So a compound is a completely different substance than the elements that make it. It has new unique properties. For example, I use this example in class. Sodium is a metal in its natural state. Chlorine is a dangerous gas or chemical that's used in cleaning products such as pool cleaners and bleach. Do you guys remember what these two substances make if they're bonded together? They form the compound table salt, NaCl, sodium chloride. So think about that for a second. You have a metal by itself and a dangerous chemical by itself. If bonded together in nature, all of a sudden you have salt, which we put on our French fries, we put on food, and we eat, and it's delicious. This goes to show you that atoms can combine in many different ways to make up all of matter that exists. Let's look at some other examples of compounds. We went over H2O, which I have some right here. Water. We have NaCl, which I just told you about. Table salt. Moving on with the slideshow, we have rust is a compound made from iron and oxygen. Vinegar is actually a compound. As you can see the formula, it's made of carbon, hydrogen, and oxygen. So here's what a bottle of vinegar might look like, and on the right you see what a molecule or the smallest particle of vinegar may look like. And we also have baking soda, made of sodium, carbon, oxygen, and hydrogen. So these are some common examples of compounds. If you looked around where you are now, you probably see more examples. There's also some in the air. When we inhale, we breathe oxygen, which is on the periodic table, so it's an element. When we exhale, we get rid of carbon dioxide, which is CO2, a compound. So I'm hoping at this point you're feeling comfortable in understanding that an element is a substance made of one type of atom. It cannot be broken down any further. And a compound is a substance made of two or more different elements that are bonded together. We've gone over some examples of each, so if you're able to name those and define an element and compound, you've successfully met this objective. I'd like to wrap up this lecture by showing you what we did with our notes on Tuesday. I had you end with a MCAS practice question. So I want to go over this just so you can understand the answer and why. It says methane and propane are two compounds that are composed of only carbon and hydrogen atoms. The table below shows some of the properties of these two compounds. So look at the table here to the left. We have methane and propane, and there's some data. It tells us the formula, boiling point, gas density. Before you make an answer, or come up with an answer, I should say, read every option carefully anytime you approach a question like this. Sometimes they'll put data in there that you might not even need to answer the question, or you might only need one part of it. So the question says, which of the following conclusions is best supported by the information in the table? This word best shows you that there might be more than one reasonable answer, but you need to pick which one best is supported by the information in the table. A says when two elements combine, the mass of each element changes. Can that be true? So if I have hydrogen and oxygen and they combine, is the amount of hydrogen and oxygen going to change? That doesn't sound right to me, but I'll keep reading the options. When two compounds are mixed, the state of matter of the mixture changes. I don't see how that relates to this data table. The data has a formula, a boiling point, and a gas density. There's nothing about what state the matter is in here, so I don't think that B can be determined by what is provided to me. Let's see what C says. Two elements can combine to produce different substances with different properties. I think that's true, right? We just talked about how sodium and chlorine are two different substances, and when they combine, they're a new substance called salt. So I know that C is true, but I still need to determine if that's the best answer. So let's see what D says. Two compounds can be mixed together to produce different materials with different properties. Two compounds can be mixed together to produce different materials with different properties. That's similar to C. I don't think anything on here shows us that two compounds are being mixed or combined in any way, though. I see two elements, carbon and hydrogen. So I'm thinking C is the best answer here. And that statement is true. We learned today that two elements can combine to produce different substances. That makes the most sense to me. So I would put C as my answer there. All right. I hope you were able to successfully differentiate between an element and a compound. Please continue today's work by answering in the discussion post that I put for you, and please complete the assessment, the check for understanding, so that I can see how you're doing with this.